Today we are driving into why fines are the silent killer of the blast furnace productivity. We know fines is not at all desired in um, the granulometry of the burden. To understand this, we have to look at the maths behind the resistance score that is denoted by K value, and we specifically focus on the most sensitive part of the um, um, Ergun equation, that is 1 minus epsilon square divided by epsilon to the power cube. So this formula represent how easily how easily gas can move through our body. So if we have ever wondered why a teeny bit of dust cause a massive pressure spike, it's all hidden right here in the following slides. So in the our next slide, which is about a very huge information, a healthy furnace, as it shows, the voidage is around 40%. That is, epsilon value is 0.40, and pressure is let it be 3 kg. So let's look at a perfect day or the very good day when the furnace is maintaining this permeability with a pressure of 3.0. What we call it is a clean shift or comfortable operation. Your stockhouse screens are working perfectly, and your burden has a very healthy voyage of 0.40. When we plug that into our mass, that is 1 minus 0.40 and divided by zero point 0.4 to the power cube, that is what we have already discussed in the first slide. The value of 1 minus epsilon to the a whole square divided by epsilon to the power cube, we get the baseline resistance score of 5.62. 5.62 is the value once we calculate this 40% void. Now at this level, when your blast furnace stay steady and safe at 3.0 kg per centimeter square. Now this is the gold standard where the furnace breathe easily and operators is comfortable, and they can have a more attention on many other techo parameters. So this we can say that what we is signified by gold standard. Now coming to the fines intervention in this static bed. So fines hiding between large coke, and these result into a reduction of voidage of 0.37. So what happens? What goes wrong? So imagine, and this all started from the perforation of a screen cogging or more generation by the material. So those both type of intervention may result in higher generation of fines and occupancy of these fines into the original void of the burden. So by doing this, your void as percentage, which was earlier 0.40, come down to a much diminished value. We have to see that just 5% extra fines of these a small particle get into the voids of the bigger space created by the coke, and these fines becomes so sneaky that they just do not they take their steps, but they intervene, they hide in the gaps between the large coke also. So this causes your voids to drop from 0.40 down to 0.37. So we can see that permeability went down from 0.40 to 0.37, which sounds like just any change. That is 0.03. But in a blast furnace, that small drop is an earthquake, and that we have to see how it's getting affected. So a chart with a some alarming lines shot up, and these pressure jump from point I mean 3.0 to 4.0 kg per centimeter squared at 41% increase. So what how it occur? Let's see. Here is the operator's reality. Because of airspace equation, our equation is cubed. The teeny 0.03 drop, which we have discussed in slide number 2, this voidage has taken they are lost, and these voidage causes the resistance score to jump from 5.62 to 7.94, as it is already shown in the slide. So that's a 41% increase in resistance. On the floor, your team see the blast furnace shot up from 3.0 to 4.2 kg per centimeter square due to this intervention of the fines, and the permeability drastic shot up due to occupancy of these fines. So at this point, you might have to open a snot valve or cut a wind volume just to prevent a hang. So a 5% mistake in the stockhouse has just crippled our production in a drastic way. So the 1% rule, what it says that fix the disease, not the symptom. So we have to fix the disease, not the symptom. Symptom is in terms of delta P increase, or we can say rise in pressure, reduction in volume. These are basically a symptom, but its disease is to curtail those fines which occupied the void and reduce it to zero point zero 0.03 level, which created a huge impact in an adverse manner. So cook were the breathing tubes, we can say. So from this, what is the takeaway? So the 1% rule says that every 1% fines you, let's pause the screen, is not a 1% problem. It acted like a 7 to 8% choke on the furnace throat. Second, treat the causes, not the symptom, that we have already discussed. When pressure spikes, many operators want to change the wind, but voidage is your most powerful lever. Changing the wind is just treating the symptom, and cleaning the fines is fixing the disease. Coke is your furnace breathing tube, and we must have to keep it clean. That is, the quality of coke should be good, and keep the void as high and your furnace stay healthy. So this is how we have to intervene our